All right, this video is for 8th grade, Module 7, Lesson 8 on long division algorithm. So we have to show the decimal expansion of 26 is 6.5, okay? The reason they're telling you what the answer is already is because we're going to break it down into an expanded form, but just to show you, 26 divided by 4 gives me that 6.5. So we know our answer is going to be 6.5, but we need to show the expansion of that. So we're going to start by writing 26 over 4. And I can break 26 into 6 times 4, which is 24, and then I can add 2 more there, all over 4. So I wind up getting, let's simplify this down, okay? I have 6 times 4 over 4 plus 2 over 4. I'm going to kind of break those up a little bit. The reason I did that is because the 4 can actually simplify this top numerator, and the 4 can actually go with this 2 and be simplified as well. Now I'm going to write this. 6 times 4 gives me 24 over 4 plus 2 fourths. And I know that 6 can go into 24 4 times. So I'm going to go ahead and make this a 6 plus 2 fourths. And I know 2 fourths can break down into 1/2. So this is 6 plus half, which will give me my final answer of 6.5. So that's how it winds up being 6.5. Let's try the next one. So again, it says use long division. It's not necessarily the long division that we're looking for. We're just looking to be able to then break this down. So to save time, we're just going to go ahead and divide this out. We're going to say 142 divided by 2, and I get 71. So we know our answer is going to be 71. It's how we're going to break it down is the part that we need to show our skills on. So we have 142 here, and I just said that your number it's going to divide into is 71. And this one isn't a 0.5 or anything. It doesn't have a repeat decimal, so it should work out very nice. So 142 is 71 times 2 plus nothing, because 71 times 2 is 142. All right, now let's go ahead and combine all of this over a denominator of 2, bringing over that denominator now of 2. So we're going to say 71 times 2 plus 0 all over 2. 71, we're going to separate them now, times 2 over 2 plus 0 over 2. And I can see right here my 2's will cancel. If I have a 2 on the denominator and a 2 in the numerator, they actually cancel out, leaving me with just the 71 and 0 over 2. Now, you can't have 0 halves. That's impossible. So this actually just cancels out altogether, leaving you with the answer of 71. And that's it. All right, let's try the next one. So this one says, does the number 142 halves have an infinite or finite or an infinite decimal expansion? This one's going to be a finite. And the reason why? The answer was 71, which means it's decimal terminated, it's a whole number, it's not a never-ending number or not a repeat number. Those two would give you an infinite. This one does not, so it's a finite. Now let's try the next one. Again, it says to use that long division, but we're just going to pull up our calculator here. We're going to do 142 divided by 4 this time, and I get 35.5. I'm going to pull this up real quick. So our answer here is 35.5. Now, I know that 142, I have to break this down now. So if I say 142 divided by 35, what's this being multiplied by? Oh, it's being multiplied by 4. Okay, well, hold on, I did that wrong. 142 divided by 35. Oh, okay, I actually didn't. This is going to be times 4 plus something. So we're going to say 35 times 4. Let's try that. There we go. That gives me the 140. That's what I'm looking for there. So we're going to say 35. This gives me here 140. How much more do I need? 2. So this would be plus 2. Now let's add in the denominator of 4. So we're going to do 35 times 4 plus 2 all over 4. Now let's separate them out because now I'm going to start to simplify. We're going to have 34 times 4 over 4 plus 2 over 4. And just like the problem we just had, the 4s are going to cancel, leaving you with a 35 and 2 4s. All right, let me see if I can bring this up real quick here. Let me get that out of the way. And so our final answer, I'm just going to write back that last step, which was 35 and 2 fourths. And I know this can break into a half. So 35 and a half, which makes sense because when we did it on the calculator, we had 35.5 show up on the calculator. So there you go. Now, is this one infinite or finite? This one is going to be another finite. All right, let's go ahead and flip it over. So we have 142 divided by 6. So let's check that out on the calculator real quick. 142 divided by 6, and I get, I have a repeat decimal. So we're going to say it equals 23.6 repeating. I'm going to drop this back down. Well, actually, let me use it real quick. So I want to know 26 times what? Or 23 times what gives me this answer here? Well, we can say 23 times 6 gives me 138. So let's start with that. So I'm going to put 23 here. And I know the 2 of these gives me 138. 142 minus 138 is 4. So I'm going to need 4 additional numbers there. All right, I'm going to erase this just so I can pull it up. That way I can show all the steps. So we have 23 times 6 plus 4. Let's bring in the denominator of 6. So we're going to put 23 times 6 plus 4 all over 6. Now we're going to separate that denominator into 2 separate problems here. So 23 times 6 plus 4 over 6. And just like our last problems, these 6's will cancel, leaving me with 23 and 4 6. Now 4 6 can be reduced. I can't divide them, but I can reduce them. And this will reduce down to 2/3. So your final answer is 23 and 2/3. Which is why I've mentioned to you guys before that memorizing 0.6, 0.6, 0.6, 0.6 is 2/3. And that's how that works out. So on C is asking us, is this a finite or an infinite? Now, since we had a repeat decimal, this is an infinite. All right, I'm going to let you guys do the last problem here on this page, which is problem 4. So you have 4, A, B, and C to do. All right, let's go to the 3rd page. Okay. Now, I want to work with you on number 5. Number 5 says, in general, which fractions are producing infinite decimal expansions? So which ones are the ones that are giving you those repeat decimals or those never-ending decimals? And as you kind of remember in the previous lesson, I mentioned that it had to be a power of 10s, which means it had to be factors of 2s and 5s. All of the ones that we've had that are infinite, their denominators are not a factor of 2 and 5. So that's what we're going to say. So we're going to say doesn't have a denominator that is a factor of 2s and 5s. All right, you're going to do number 6, and then I'm going to work with you on number 7. So go ahead and do number 6. I'll meet you back on 7. So number 7 says, does 17/11 have an infinite or finite decimal expansion? Now we could just go ahead and grab our calculator here and say 17 divided by 11. All right, we can tell right away there's a repeat. So definitely this is an infinite, okay? Another reason why is because 11 isn't a power of 10, which means 2 and 5 cannot divide into 11. 11 is prime. That also gives it away. So we're going to say the denominator is not a power of 10 and is already in the simplest form. So I couldn't even reduce this fraction if I wanted to. It's already in the simplest form because both numbers are prime. So our final answer here is it is infinite because of that repeat decimal. All right, let's go on to the next one. Now you can tell here we have this crazy long answer, but is it a pattern? So I have 2, 1, 2, 1, 1, 2, 1, 1, 1, 2, 1, 1. It's a pattern, but it's not a solid repeating pattern. It definitely is changing, so it keeps progressing. So because it keeps progressing, it wants to know, is it a rational or irrational number? This is going to be an irrational number. Okay, for it to be rational means it has to terminate or it has to have an actual pattern. Now this is irrational because we're going to say not a repeating pattern. Therefore, it can't be rational. Now, rational means okay. I hate to use the word normal, but normal. It's a normal looking number. Irrational is going to be something that you can't control. It's all over the place. It doesn't look right in that sense. All right, let's go ahead and do number 9. Number 9 says 860 over 999 thousandths. Is it infinite or finite as well? So let's check this out. We're going to pull up our calculator. I'm going to clear that out. I'm going to say 860 divided by 999. And I get a long decimal, but notice the pattern, 860, 860, 860. So we definitely have a pattern here. So in this case, we're going to write that 860 over 999 comes out to 0.860, and all 3 of those numbers repeat, therefore making it rational because it has that repeat pattern. And we're also going to say it's infinite. And that's because the denominator is not a factor of 10, powers of 10. All right, I'm going to let you do number 10, and that ends this video tutorial.